In this video, we illustrate how it's possible to use several of the available products in Tigra Tools for designing a full antenna system, and how the antenna performance may benefit from such a full system approach as an alternative to designing the antenna subsystem in different programs. As an example, we'll be considering this antenna that consists of 4 reflectors, each fed by an array of feed horns. The purpose of this antenna is to produce so-called 4-color spot beams over Australia in Ka band at both receive and transmit frequencies, as illustrated here. What we'll be showing in the video is that it's possible to optimize this full antenna system in Tigra Tools, and that the full system design may improve the antenna performance by improving the spot beams on the ground. This is possible by simultaneously using POS for shaping the reflectors and CHAMP 3D for designing the feed horns in the feed array. Before optimizing the full antenna system, we'll focus on optimizing the feeds in the feed array. For this purpose, we switch to the Tigra Tools project, where we have set up the antenna system. We see the 4 reflectors, shown with different colors, each fed by an array of feed horns. The design of the feed horns is done in the Feeds and Waveguides tab that's available with the CHAMP 3D. So we switch to the Feeds and Waveguides tabs, where one of the feed horns is shown. What we see here is essentially the feed horn exterior. If we add a so-called cut plane, we may inspect the horn interior as well. This interior has a certain profile, which is what we will be optimizing here. We can also inspect the horn interior by switching to this 2D view. Here we see the horn represented with an input port to the left, a radiating aperture port to the right, and in between we have several linear sections that are connected at the black boxes. And the radius at these connection points are the feed design variables that we will optimize to get the optimum feed horn profile that'll ensure the best illumination of the reflectors in the antenna design. With this in place, we can proceed to the Optimization tab, where we have set up the optimization. At the top in the middle, we have the variables used in the optimization. Here we have the 5 feed horn radii, the free variables in the feed design. These have some initial values, and we have applied bounds on the variables in the min and max columns. At the bottom in the center, we have the goals used in the optimization, where we have specified both at RX and TX frequencies the desired goals for both blue and green beams that operate at the same frequencies. The type of goal we use for specifying quantities such as desired peak directivity, edge of coverage for each of the beams, the XPD of the individual beams, as well as the C over I, is goal multibeam. And we can illustrate one of these goals, the C over I goal. It is a multibeam goal. We have the desired beam width, which is specified to 0.8 degrees, and we have set the goal type to C over I power sum. Other types are available and used in other goals in the optimization we'll be running. Finally, we have the goal specifications with 22 elements. It's displayed in this table, where each line corresponds to one beam that we like to have at certain UV coordinates in the far field. And the other beams then, for this goal, contribute to the interference when computing the C over I. So we have the variables to be optimized, we have the optimization goals for the green and blue beams, all set up inside an optimization manager called Optimization Manager GB, as we see here at the top. To run the optimization, we simply go to the Commands tab and run a single get optimum command for the optimization manager. This will then optimize the feed design for the specified goals. We have run this optimization for the feeds alone, that is. And the initial performance is shown here, where the worst performance for any of the green or blue beams is shown. We start with a peak directivity of just over 47 dBi, an edge of coverage of almost 41 dBi, a C over I over just 12 dB, and an XPD of a little more than 15.5 dB. Then we optimize the feeds in Tigra Tools to get improved performance that we see here. We get a slight increase of the edge of coverage, a substantial 2 dB increase of C over I, and a small increase of the XPD. So by optimizing the feeds alone, we have improved the antenna performance. However, as mentioned, we would like to optimize the full antenna system by again optimizing the feed design with Champ 3D and reflector shapes using POS, all inside Tigra Tools. We return to the Tigra Tools project, where we still have the antenna set up, and we would now like to simultaneously optimize the feeds and reflector shapes. To this end, we return to the Optimization tab and add the variables to shape the reflector surfaces. We click here to add a new variable of the type bulk optimization variables, reflector shaping. We click on the target reflector and then on OK, and finally we add this new variable to the list of variables used in the optimization. So we'll again optimize the radii for the feed design, but now also shape the reflector surfaces for the same goals as explained earlier. This is all specified in the Optimization Manager. And we once again run the getOptimum command for the Optimization Manager. This new optimization starts with the feed design we obtained in the first feed-only optimization job, and the start performance is therefore the numbers in the Optimized Feeds column in the table. When we optimize simultaneously the feed design and reflector shapes, we get this performance. We get a small degradation of the edge of coverage in XPD, but the limiting quantity, the C over I, is improved by almost half a dB. Thus, we pay a small price on some of the other quantities to improve the C over I when optimizing both feeds and reflector shapes. This concludes the video where we have optimized both the feed design and reflector shapes by using Champ 3D and POS, respectively, inside Tigra Tools. The example has illustrated how the antenna performance may benefit from optimizing the full antenna system instead of optimizing the individual subsystems, and this is possible in Tigra Tools. If you want to know more, you can contact us on info@tigra.com.